All right. Shut up. Okay, so homework assignment. You were supposed to write a method that takes a string as a parameter, and well, let me get rid of this square method for right now so it doesn't clog things up. Takes a string as a parameter and displays that string in reverse, correct? Okay, so as of right now, we have a method that takes a string as a parameter and displays it one character per line in forwards order. So I'm passing it hello. This will print out hello forward. So we want to make that backwards. So rather than going from bucket 0 to bucket 1 to bucket 2 to bucket 3 to bucket 4, we want to go from bucket 4 to bucket 3 to bucket 2 to bucket 1 to bucket 0. Okay? So we want to walk backwards. So we're going to go into our method. We're going to change I to start off at s dot length minus 1, the last legal position in our string s. All right, so if s happens to be the string hello, this will boil down to a 4. If it happens to be the string elephant, it'll boil down to a 7. Make sense? So the length of hello is 5. The last legal position in it is 4. So we're going to start off with the last legal position in it. We're going to keep going as long as we are greater than or equal to 0, which is the first legal position. We also want to include 0. So you don't want to say greater than 0. You want to say greater than or equal to. Okay, you could say greater than -1 if you wanted to. Those are the same. And instead of adding 1 to I each time, we want to subtract 1 from I each time. So we'll go from 4 to 3 to 2 to 1 to 0. Then 0 becomes -1. Is -1 greater than or equal to 0? It's not. So we'll fall past it, and the method will end, which will put control back to main right here, and then main ends. Make sense? All right, so we'll run this, and this should give us hello in reverse. Similarly, if I pass it elephant instead of hello, we'll get elephant in reverse. You should not have to change your code at all. Okay, now, a couple people who come and ask for questions, they came in here and they hard-coded this to 4. Why is that a bad idea?
It just
limits you to strings that only have 4 characters or have 5 characters in it, right? So this will only get part of elephant. But what if I pass in something smaller than? We'll get an error, array index out of bounds exception. So this exception, this array string index out of bounds exception, means that we tried to access a bucket of our string that did not exist. It's the punchline of it, okay? Make sense? All right. Now, just to review, because I did have a couple of people who had this issue, one thing to really think about for your loops, because what a loop is a setup to take most of the time for us, take an integer on a voyage between some number and some other number. And then we utilize that number for some purpose. So when we think about a for loop, this first part is what number do we want to start with? The second thing is how long should we keep spinning? As long as I is greater than or equal to 0 in this case. So we'll start at the length -1, keep going as long as we're greater than or equal to 0. What do we want to do to that number each time? Those are the 3 parts of a for loop. Make sense? Okay, so if you can kind of remember that, break it down, writing this header for a for loop should actually be pretty easy. Where do I want to start? How long do I want to keep going? What do I want to do to the value each time through? Okay? Then the body of it is just, now that I have a particular value, 4, then 3, then 2, then 1, how do I want to utilize it to solve some problem? Make sense? Okay. So now remind me, what is the difference between a method that returns a value and a method that displays a value? So if I were to ask you to write a method that displays a string like this, as opposed to a method that returns a string, what's the difference between those two? Go ahead.
For one displaying anything you need to avoid.
Okay, if it only displays, if its only purpose is display,
right,
the return type would be void, because we're not actually returning any value.
Mm-hmm.
We're just taking some inputs and we're displaying something to the screen as a result of those inputs.
Right.
Okay? But if we're having a method return something, there's no guarantee it will ever actually get displayed to the screen, right? It'll only get displayed to the screen if we took that return value and told it to display. So methods that return something are typically taking some inputs, doing some magic tricks with those inputs, spitting out some value of some type, and then we use that value in some other way. We might use it to display it, we might use it as part of another math problem, whatever, but there's no guarantee it'll actually get displayed, as opposed to a method whose purpose is to display. And I'm just using those as examples because that's kind of a common mistake that beginning programmers make, is this concept between write a method to display something and write a method that returns something. Okay, those are two different tasks. Displaying something is just showing it on the screen. Returning something is giving it back so we can do something with it. Okay, and that will dictate what the return type will be. Okay, as an example, if we write a method called display that displays a string, in this case, it's displaying it in reverse, as opposed to we will purposely name it the same thing. Okay, we're going to purposely name this method the same thing, even though the name of it won't make any sense. We'll change the name shortly, but just to kind of give you an idea. And this guy's going to take a string as a parameter, and all we're going to do is return that string. Oh, that's interesting. Okay, so now we have two methods named display. It doesn't like that. What do we call two methods with the same name and a different number and or type of parameters? What's that? What's the crazy term for that kind of thing? Polymorphism. Polymorphism. More than one method, the same name, but a different number and or type of parameters. Do both of these methods have the same name? They do. Do they have a different number and or type of parameters? They do not. They both take one parameter, and both of them are of type string. Now, if I named this guy blah, is that going to fix everything? No. The name of the variable does not matter. Both of these guys are name display, and they take a string, a single string. Okay? Now, if I had this guy take an int b as a secondary parameter, then it would work, even though we don't use b in here. By making it take an integer b, now it's not broken anymore. Okay, but notice when we had them both take strings, it's still broken because even though these guys have a different return type, this one being a string, this one being a void, because they have the same name and the same number and type of parameters, we're breaking the rules of polymorphism. Make sense? So we can't name this guy display. So we'll go ahead and name it. Here, I'll give you another broken example. We'll name it return. Okay, doesn't like that one. Why can't we name our method return? Yeah, well, return specifically is a very important keyword in Java, right? So we can't name our variables or our methods the same thing as our keywords. So those are special words that we can't use as our method names. Now we could call it return val. That's no problem, because return and return val are not the same word. Okay, so we'll call this guy return val. he's going to take a string as a parameter, literally do nothing with it, and return that string. Now, why do I have an error around this S right here? I changed the name of my parameter. So now if I want to return blah, well, really what's it complaining about with S? It's saying I don't know about this variable. There is no variable that was defined called S within the scope of this particular method. So when I change this from S to blah, I need to make sure that anywhere inside of here, I also update that. Make sense? So it does not matter what your variable names are called in your parameter list, as long as whatever you call them up here is how you use them inside the body of the method. All right, so now we have one method called display that takes a string as a parameter and displays it. And we have another method called return val that takes a string as a parameter and returns it. So if I were to call that second one, hw.returnVal yes, what will the output of this program be? The yes backwards how many times? Will there be anything else? Yes backwards. What happened right here?
Pulled the method, but you didn't really tell the method to do anything other than the return, which doesn't really show anything to the screen.
Okay, doesn't show anything to the screen. So this guy, what does this guy boil down to?
Boils down to return block.
Boils down to the string that was passed in. Okay, and what am I doing with that string? Nothing. So this is kind of like in a professional baseball game, a pitcher pitching without a catcher. Just throwing it at the fence, and it just disappears into oblivion in this particular case. So if I want to do something with that value later, I can store the result inside of a variable, and then if I wanted to, I can display it. It's not the method that's displaying it. I'm getting the value back from the method, and then I'm choosing to do something with that value. Make sense? Now, I'll unprint it for a second here. I'm going to go ahead and change this variable name from val to blah. Is that legal? But isn't it taking blah as a parameter here? Aren't those going to conflict with each other? So I'm passing this string yes into blah, yet I'm catching it inside of a variable named blah. Is it going to get confused? Why not? Randy?
Is it because that instance of blah only lives within the scope of that function?
Yep, so it's the scope of these variables. This blah, so yes, if we were to draw some lines, yes will get connected to this variable blah. This local variable that lives and dies with this method right here. Okay? So blah will get set equal to the string yes, or the pointer that points to where yes lives in memory. Then we're going to use blah in some way inside of here. In this case, we're just wasting our time and literally doing nothing with it. This is pitcher throwing it to the catcher, and catcher just throwing it right back, and not painting the ball, which is pretty common in baseball, right? That's probably cricket. Do they do something weird with the ball in cricket?
Yeah, they throw it like over their shoulder or something.
Really?
Yeah, it's like a running throw.
Man, that's like a made-up sport, cricket.
I don't understand. That's just a game.
There's wickets. It's like a mixture between baseball and bowling. And I guess week-long vacations.
I like the week-long vacation part.
Well, but you have to spend it at the what's it called, the cricket pitch? Yeah, I think they call their stadium the pitch.
Ask Siri.
Siri will probably misinterpret pitch to be something else.
I'm not sure I can answer that question.
yesterday in operating systems, I had to be very careful to enunciate clearly. We were talking about forking, which is the predecessor to multi-threading. And then it really went downhill from there. You know, because you get situations like the parent forks the child, and then it's just bad news. There's actually some really funny phrases in computer science. You know, forks don't exist anymore. Now we do everything with threads. That's the safer term. But this one time, I was when I was a Unix system administrator at Western Illinois University. We were out at breakfast or lunch or something like that. We were talking about this program, me and the other admins, and it was a program that kept forking off children. Okay, so there's like this old lady sitting at the table behind us. All right, so we're talking about forking children, and then we had this extra program called the Reaper, which went out and reaped the forked children, you know, to get rid of those processes. This lady looked at she's like thinking about calling the police. We're talking about some sort of like sick heist, yeah, a sick demonic cult type thing. It was pretty funny. Then we had to explain to her, oh no, we're computer programmers and we're actually just talking about a program, and we kind of get what you mean. This was before phrasing, right? Yeah, phrasing was just invented with with cartoon.
How old are you?
Huh? Older than you. It just turned 24. Are you 24 yet?
October 13th.
Oh, see, I'm older than you. I'm a little older than 24.
A little.
How old do you think I am?
33.
Oh, guess low.
46.
I've been teaching 15 years.
I'm going to say 46. 44.
44. So you went from 33 to 44, 11 years and one comment? Got the receding hairline, but I've been told that some people get that when they're like 8.
Don't judge me.
Well, yeah, I cut my hair short. Yours is probably the same as mine. Just your hair's longer.
Just wait till the end of the week.
This is your comb over?
Yeah. I grew it out for a little while before I grew it.
I am 37. Yeah, see, I got my PhD. You're 23?
Yeah.
I got my PhD when I was 22. You're so slow.
I was in Germany for a while.
What was I talking about? Oh,
Forking.
we were talking about forking children. It is recorded. But I have enunciated it as the word fork. F-O-R-K. Computer science term. All right, shut up. All right, so it makes sense the difference between a method that displays something and a method that returns something. Now, you could have methods that display something and then return something. So we can come up here to our display method, and after it displays, we can just have it return it. Okay. Why is this red?
Because you have void.
Java requires that we tell it the truth. Okay. So if we are going to return a string, we better tell Java that we're going to return a string. If we tell it void, that means we do not intend to return anything. So if you try to return something, Java's going to be unhappy. Okay, so now we're going to return that string S, and we're going to do nothing with it because we didn't set up the catcher to put it anywhere. Okay, now I can either put it in a variable, or can I do this? Let me just get rid of the second line here for right now. Is this legal? But this is the method call. Does system.out.println know how to print methods? When we looked at it as a polymorphism example where there's a version that knows how to print bytes and shorts and ints and longs and objects. Is there one that knows how to print methods? So is this going to work?
Print the result of the
So I'm not asking it to print a method. This whole thing right here resolves to a value, right? And what value does it resolve to? Something of type, whatever the return type of display is. In this case, string. So everything I have written in here ultimately turns into a string. And system.println does know how to print a string. So this is going to take in yes. Well, what's the output of this program going to be right now? Remember, all programs begin and end with main. So when we start our program, we're going to start right here. And we're going to only follow the instructions that it tells us to do within main. So even though we have this extra method down here, that method's never actually being called. It's an untapped resource. This is the method definition as opposed to the method being used. So what's the output of this program going to be?
Should be yes. But not backwards. Straight.
Yes, but not backwards? Who can tell him why he's wrong?
Boiled down. I bet you can put the method.
Confident I could. See, the point is when a professor is just guessing, then I can just say, oh, somebody tell him why he's wrong, even though I don't know. And then if I end up being wrong, I'm just tricking you. No, he's definitely wrong. So let's follow through this. We come into the main method. We need to now, before println can work, we need to resolve this value. And how do we resolve this value? Well, we need to transfer control to this method down here, passing yes in as our string s. So s in this particular call to this method is equal to yes. All right. What does this method do? Goes from bucket s.length minus 1, which will be bucket 2, to bucket 1, to bucket 0. What does it do each time? Prints it out. So this will print out S, E, Y. Is that your wake-up alarm?
That's my wake up alarm because I didn't know if I was going to wake up.
Oh, I got you. I would have excused you from class, by the way, for your headache.
I don't really know for sure. It's really unclear.
It's what?
It's really unclear sometimes.
Well, if you would have asked me, if you just said, I have a really bad headache and I'm not sure I want to deal with your booming voice in class, I would have excused you. Minor headaches, no. But he's got another. As long as you're not using it as an everyday excuse. If you have a migraine problem, you should probably go see a doctor. But I understand sometimes there's issues that make it so that it would be easier for you just to watch the lecture when you feel better. Okay, so this guy's going to go through and print out S-E-Y. And then what is it going to do? It's going to return yes. So this guy then ultimately boils down to the string yes. And then this guy does what? Prints it. Okay, you see how we followed it in the way that it resolves. So this guy's going to do S-E-Y on 3 separate lines, followed by the word yes all on 1 line. Make sense? Okay. Now, remind me, is this a class method or an instance method? How many think it's an instance method? How many think it's a class method? 1, 2, 3, 4. Really crappy voter turnout. Everybody else is voting independent. Okay. You said it's an instance method? Tell me why it's an instance method.
Because you're not calling a class up.
Let me ask you a follow-up question. Is this me using a method or me defining a method?
Defining.
It's me defining a method. So I wouldn't be calling it anywhere. And this is the definition. So if this is the definition of the method and you say it's an instance method, why isn't it an instance method? This is a class method. Why? At the definition. One word. Okay, let's pick a different word. We're running out of words in that line. Static. Static. The static keyword at definition makes it a class method. So how can we tell a class method at definition? Because the keyword static is present. How do we tell an instance method at definition? At method definition, because the keyword static is not present. How do we call class methods? Not define them, how do we call them?
Class key.
Using the name of the class in which the method was defined. So here's the display method. Here's the word static, which means it's a class method. So we've identified this defined method as a class method. So we need to call it using the name of the class in which this method was defined, which is the class name HW. So we call it right here. This is an example of us calling that method HW.display. Okay? As opposed to the length method here, which is an instance method defined inside the string class. We haven't seen it yet, but do you think if you were to look at that method definition, would it have the word static or not have the word static in front of it? I already told you it's an instance method. No static?
No.
You confident? Bet your whole course grade on it?
Yes.
There would not be a static in front of it. Okay? How do you know? If I hadn't told you it was an instance method, how would you have told me, or how would you have convinced me that you know length is an instance method there? If I told you it was defined inside the string class. All you need to look at is what I have highlighted. If I told you length is a method defined in the string class, and I asked you to tell me, do you think it's an instance method or a class method? What would you say? And then you have to defend it. You got it, Randy?
Because it's not using the, it's not starting off with the name of the class.
It's not starting off with the word string. If it was a class method, that says I've told you it is defined inside the class method. Since we're calling it here, we're not saying string.length, we're saying s.length. And s is an instance of the string class because it has that is-a relationship. S is a string. So how do we call class methods? We call them using the name of the class in which the method was defined. How do we call instance methods? We call them using an instance of the class in which the method was defined. Make sense? Okay. How do we define class methods? Using the static keyword before them. How do we define instance methods? Don't write the static keyword before them. That's at method definition. Makes sense? The two separate sides? It's highly probable at some point in the near future you're going to have a quiz where I ask you, how do you define instance methods? How do you define class methods? How do you call instance methods? How do you call class methods? 4-part quiz. All or nothing, graded in binary. Okay, so let's learn a new skill now. String concatenation. This is a tool, well, yeah, that's fine. A tool for building string objects. It uses the plus sign operator. Now, when we see a plus sign in a Java program, we typically think addition, math stuff, right? Well, the plus sign can be used in two separate ways inside of a Java program. It can be used to do math, or it can be used to do string concatenation. Okay? And Java figures out which you mean by the context in which you're using it. Right? So, for example, if I have the string hello, and I have the string world, this will produce the string hello world. If I want to throw an extra space in there, I could either put a space before world there, or I can concatenate on the string, except we need to put those plus signs in some better spots. I can say hello concatenated with the string space, which will produce a brand new string, which will be hello space, then concatenate onto that string, the string world. That make sense? And that will produce this. Instead of using the string space here, can I use the char space? Will that still work?
Separate. Should.
Okay, well this isn't a string though. How is it going to know I'm doing string concatenation? Because there's a string on at least one side of the concatenation operator. All right, so it's going to break this down into multiple steps. This is the first part. It's going to take the string hello and concatenate that, and concatenate onto the end of that the char space. And since we have a string at least on one side, we will have the result of concatenation will always be a string. So we can even write that. The result of concatenation will always be a string. So this first part here, we're going to take the string hello, we're going to concatenate onto that the char space. Since there's a string on at least one side of that, it's going to treat the plus sign as the concatenation operator rather than the addition operator, and it's going to build for us a new string, because the result of concatenation is always a string, and that string will be HELLO space. All right, then we're using a plus sign again to concatenate on world. So we're going to get HELLO space and then world. Make sense? Now, can I legally do this? Why not?
That's char, and the char's only one character.
Okay, so the single quote is how we designate something as being a char type. And chars are exactly one character long. So this is not a legal char. That makes sense? So the reason we can't do that has nothing to do with the fact that we're trying to concatenate on a char. It has to do more with the fact that this isn't a char. We're representing it as a char, but it's kind of like throwing a tissue on top of a car and expecting it to hide it. All right, concatenation makes sense? Okay, so now we can use that tool to write a similar method that we had for homework, where we take a string in as a parameter and return that string in reverse. Make sense? Instead of printing it in reverse, we're going to build a brand new string that is the original string backwards. Because now I can concatenate. So we'll leave our display up there for right now. And let's just take off the return statement from that. And we'll make it, turn it back into a void. So we'll go back to our solution for our homework there. And notice now, we can't print this because this guy's not returning anything to print, and it's going to say we can't print a void value. So we'll just make our call. So this will be back to printing out yes in reverse. Okay, but now we're going to write another method that's going to return a string called reverse. That takes a string as a parameter, and we want to return a brand new string that is the original string spelled backwards. Okay, so whenever we're building a string, it's pretty common for us to start with the empty string. That is a string with 0 characters in it, but it is a string. Therefore, when we use the concatenation operator with it, at least one side will be a string. Does that make sense? Now I want to spin through my string S. And I want to build S inside temp, but backwards. So don't even think about the reverse portion of this yet. How do I write a loop that will take, let's just say we're going to use the variable I again, that will take I on a journey from the end of S to the beginning of S? That's all we're doing. We're not doing a concatenation yet. I just want to write that loop. And even though we already have it on the screen from our other method, you're going to explain to me why you're starting with each part, whoever's going to help me here. Because copying isn't learning. So I'm going to write a loop, so I'm always going to start with the word for, since it's a for loop I'm writing. All right. Now I need to create my starting point variable. And I said we're going to use I. What are we going to start I as being equal to? If I'm going to go through S in reverse, we want I to start off where? Generically speaking, the last legal bucket in S. Now, how many characters are in S? Okay, I like that answer. I like that answer better than somebody saying 3. Did anybody say 3? Joel, say 3. Idiot. 3 is bad. It's 3, it means you're looking up here and saying, oh, well, S is going to be yes, and that has 3 in it. Okay, so I asked, how many characters are in S? And you said, who knows? Well, who knows is better than 3. But we actually do know exactly how many characters are in S. Somebody else said the answer. S dot length number of characters. If S was yes, it would be 3. If S was elephant, it would be 8. If S was hello, it would be 5. Make sense? So S dot length is the way we can ask for any variable that's capable of holding a string, how many characters are in you? All right, so what's the last legal bucket of S? If its length is S dot length, the last legal bucket in it is what?
Length minus 1.
S dot length minus 1. Because strings are indexed from bucket 0. So a string with length 5 will have legal buckets 0, 1, 2, 3, 4. Length 3, 0, 1, 2. So on and so forth. Okay? So we're going to start I off at the name of our string, S, dot length. This right here boils down to the number of characters in S. All right, so what I have highlighted there, even though it looks like a method call, ultimately boils down to an integer. And then I want to subtract 1 from that. So I want to start I off at the index. Assuming I'm going to use that number to index my string, I want to start it off at the index that is the last legal bucket in S. Make sense? So that's where I'm starting off. How long do I want to keep spinning? In this particular case, we're reversing our string. So I want to go on a voyage between the last legal bucket and the first legal bucket. And I want to make sure I don't forget about the first legal bucket. I need that one too. So how long am I going to keep going for? I need a Boolean expression. What's a Boolean expression? Any expression that boils down to a single value of true or false. Okay, so what's the Boolean expression I'm going to write here that will make this loop continue to spin as long as, well, continue to spin until I get to the first legal bucket, including the first legal bucket of my string. I is greater than or equal to 0. Okay, so I'm going to keep spinning. My loop is going to keep looping as long as that Boolean expression boils down to true. As soon as it's false, we're done. Now, what do I want to do to I each time? Take 1 away. Common mistake for beginning programmers here is we get increment diarrhea. Okay, it's a little bit less of a severe condition than curly brace diarrhea. Okay, but increment diarrhea is we have this preconceived notion because we write for loops so often that we just automatically do an I++ there. Almost like not even thinking about the last part. I mean, it's not stupid. It's just we fall into these patterns. And we'll start seeing that we're going to have patterns of solutions. So there's kind of multiple levels of programming. We're going to have to understand the tools that are in our toolbox. We're going to have to understand some of the different structures that we have and making sure we don't have syntax errors like missing curly braces and semicolons in the wrong places and that kind of stuff. That only comes from experience. The tools you buy, you memorize. They're in your toolbox. You can go and look them up in your notes or something like that. Okay? But the things in the middle, those are kind of like mistakes. Things you learn through experience. Like if you are a contractor and it's your first week on the job and you've never done this before, you're going to probably make some stupid mistakes. You're gonna, cut lengths of wood the wrong length. You're gonna on the wrong side of the line or measure it incorrectly, stuff like that. But over time, after you've made all those mistakes, you're gonna become more and more competent, right? Sometimes you need to get punched in the face a few times before you start realizing that, okay, if I have to go back and recut this wood 4 times, that's why they have the saying, right? Measure twice, cut once. Some of us need to measure 6 times, cut once. Well, yeah, but you're handy. Yeah, so I've gotten pretty good at the measure twice, cut once part, but everything else I just MacGyver. Like I think I was that in this class where I told you about the installation with the screwdriver. Yeah,
I cringe.
I bet you that air conditioner is still installed because there's no way they can get that thing unjammed from that foundation.
With the chair.
Kind of like the time in the same house when this was back when big screen TVs, they had the rear projection CRTs that, not something you hang on your wall, but something that you put in the back of a large pickup truck. And Best Buy was delivering this thing. This was years ago. It was a 65-inch rear projection CRT, and rear projection LCD rather. And so super heavy. And I had a staircase in the house that went down, then it had a landing, then turned back. And they refused to take it down there. But being a scientist, I had done all the measurements and stuff. So I had one of my students come over, and we probably still have video somewhere. We have like tow ropes like attached to me where I'm like trying to control the weight as he's making the turn. Something zigged when it should have zagged. And the tow ropes came off, and this TV went gliding down the first flight of stairs through the wall. Okay. But then we were able to back it up a little bit and make the turn, and everything was fine. Well, except the wall was damaged pretty severely. But we fixed that, and the TV, we got it down to the basement. Worked fine. Yeah, no problem. It was only like a 15-foot slide. So, and the TV weighed probably a couple 100 pounds. Probably less than that. Probably just seemed like it weighed a couple 100 pounds. I bet you it weighed maybe 120 pounds or something. So no big deal. Maybe there's a couple of scuff marks on the side of the TV, but it was fine. It was fine. So we fixed the wall-ish. Never looked right. But I sold that house with that TV in the basement. My house right now, we have a similar type of, not quite as bad, but a similar type of stair landing thing going down to the basement. And when I first started my software company, AwesomeFat, we worked out of the basement of my house. And we got, we tried to make it all, cool and, Google-esque type stuff. So we got this old classic Pepsi machine. Older than the one, if you've seen the one in there. So this is back when they used to have lead in the bottom of this thing. Oh, God. This machine weighed, I bet you, nearly 1,000 pounds. It was so heavy. So we have a video somewhere. It's like 8 people trying to move this thing down there, and we got it down in the basement. But there's no way that thing's coming up. They would have to like put a hole in the floor and then bring a crane in and hoist it, hoist it up. Yeah, it was entertaining. Okay, so anyways, yeah, we got off on that tangent related to. Even if you're doing something non-programming, when it's your first time doing it or your first 50 times doing it, you're going to be prone to mistakes until you've kind of made those mistakes and you start adding it to your list of things that you need to check before you, in this case, cut the wood, right? All right, so we're going to write this little loop. This loop's going to start off at the index that will be related to the last legal bucket in our string. We're going to keep going as long as we are greater than or equal to the first legal bucket of our string, and then we need to remember that we actually want to subtract 1 from I each time, when it might be easy for us to just haphazardly put I++, because we put I++ so often. Make sense? Okay, now, we are not displaying this string in reverse. We are building this string in reverse. All right? So each time through, we need to concatenate on the current character we're looking at onto temp. So the first time through, if S was yes, the first time through, we're going to concatenate onto temp. So temp starts off as the empty string. We'll concatenate on the S. Next time through, temp will be equal to the string S. We'll concatenate onto that, the E. Next time through, we'll concatenate onto that, the Y. Make sense? How would I write that line? Your toolbox contains everything you need to write that line. I'm setting the variable temp to a new value. Go ahead. Yep.
Temp equals temp plus s at s dot char at I.
Okay. So we're going to set temp equal to whatever temp is currently equal to, concatenated with, and we know this is going to be concatenation because at least one side is a string. This guy's a string. What kind of animal is this guy? Cat, dog, string, int, char. You bet your grade on it? So it didn't sound like you would bet your grade on it.
Well, it has char.
Oh, just so it has the word char in it, that's why? If S happened to be equal to yes, and I said S dot char at 1, what would we expect to get out of that? S is the string yes, and I say S dot char at 1. What would I expect? E. What is E? Cat, dog, int, string, char. What is E? It's a char. Okay, so this guy boils down to a char. Not because it has the word char in it. It has the word char in it because it boils down to a char. So the person who named it tried to name it something reasonable, right? Get me the char at a particular position. All right, so the current value of temp concatenated with the current character we're looking at will produce a brand new string that we will then store back into temp. So the next time through, temp is now a brand new value. So it's already been modified from its initial starting point of the empty string. That make sense? All right, now, do I just print it out? Return it. Okay, so we started off with the empty string. We built a loop to go through all the characters of S backwards. We built up temp to be S in reverse. And then when we were done, we returned the value of temp. So we'll go ahead and call reverse now. Reverse, class method or instance method? I'll remove this line so we can practice. Class method or instance method? Class method, how do you know? Static. So at the method definition, we see the keyword static. How do we call class methods? Using the name of the class in which the method was defined. What's the name of this class? HW. So HW dot reverse. And we'll pass it yes. All right, so what's the output of our program going to be? If anybody should know this, the doctor lies. Huh?
All you're doing is
It was a Doctor Who reference, but I'm also a doctor.
those street ties are cool.
I don't see the police box.
Huh?
I don't see the police box.
I wouldn't fit in that police box. It's a good thing it's bigger on the inside than the outside.
You gotta get through the door though.
That's my argument. Why you asked me at the beginning of class? Why if I bet my 6+ yet? I posted online somewhat jokingly, but I actually think it's kind of a true statement. You know, it's not an Apple problem; it's a skinny people problem. If you had bigger pants, you wouldn't have this problem. It's these normal sized people that have, you know, what the skinny pants where the pants can barely fit onto you. They're basically skin tight. I mean, put a wrench in your pocket, you might bend it a little bit. But no, my pockets are more like reservoirs, like backpacks. So I could put like 5 of these in my pocket. It would be fine.
iPad Air.
Almost. I could fit a mini. I think I told you guys. I could fit a mini in my pocket, but yeah, not an Air. So it's like one of the advantages of wearing size 58 pants. I bet you we could take a couple of you in here, and 58 is bigger than your 2 waists put together.
I wear 28.
See? So all we need to do is find another 28 in here. we're sitting at 56. We're good. So you just imagine how much more space you'd have. Plus, they build fat guy clothes differently. Yeah, normal people clothes is like they're like fitted. Now, fat guy clothes, they just take a bunch of material, connect it, and just say, okay, they're going to need the extra space. Otherwise, you sit down and you split everything, right? Now we're just going to make them clown pants. We want to give them some room to move. All right, so that's why I don't anticipate having a problem. But then I read about these people keeping the phone in their back pocket. I would definitely have a problem with that.
That's being stupid.
Just crush factor. What's the iPhone 6 Plus crush factor? Yeah, that's 370 pounds of downward force between a phone, a hard seat, and whatever, bone is pushing into it. That's the type of stuff you find on construction sites. All right, so in any case, what's the output of this program going to be? Oh, I got your new nickname, Fuse.
Oh, no.
That's a good backstory. He missed class the other day. He texted me that his alarm clock, the fuse blew.
Yeah, I heard the alarm clock when I was getting ready.
It's like, oh yeah, what year is this alarm clock from?
It's one of those like $5 alarm clocks that you buy at Target. Yeah.
It has a fuse in it.
Yeah.
All right, I want to see this. I want to see the alarm clock with the fuse.
Lemon, I will tell you, I heard the alarm clock coming out of his room.
All right, that doesn't mean
No.
that doesn't mean the fuse didn't blow after the alarm clock was going off.
I heard it for like 20 minutes.
Oh, today?
No, the other day.
Oh.
Tuesday. So
Well, he misses so many classes, so it could have almost been any day.
It wasn't
Yeah.
Tuesday. It was Saturday morning.
Oh, that's right.
Remember?
Oh, she's killing
It
me.
wasn't for class.
All right, so what's the output going to be?
Nothing.
Nothing. Why nothing?
Because you're just returning it.
I'm returning this value here, so this guy's going to boil down to that return value. And what am I doing with that return value?
There's no
What am I doing with it?
You're storing it for another.
Am I?
Well, for another time, you're going to use it.
Am I? Look at the code. What am I doing with it?
Reversing it. And
Call in reverse. Reverse ultimately returns that string in reverse. So this guy right here is going to boil down to yes in reverse, right? And what am I doing with it? Nothing.
Yeah.
I'm not storing it anywhere. I don't have a variable defined there to catch it. I literally just wasted my time. All right. I put a piece of paper into a scanner and walked away. Didn't even pick up I put it into a copier. Didn't even pick up my copy. I also left the original. I really use it as a trash can, is what I used it as. But I wasted a little paper along the way, as an environmentalist would. Okay, so the output of this is literally nothing. Okay, no output. But I'm also not doing anything with this value. If I want to store the value, I'd have to create a variable, because variables are how we store things for use later. So I might store it in a variable called blah. So now that I've done something, what's going to be output of my program?
Oh, it's going to display yes backwards.
Okay, did you actually read the code? You just assume that I wasn't lying to you.
Well, you have static. Yeah, it's going to display string s backwards.
Tell me where in this line it says display.
Oh, it's reading the next line.
What next line? This one? That one definitely doesn't say display.
No, the next line.
This one?
Yeah.
Oh, we don't even need that one anymore. That was an untapped resource. We're never calling that. All programs begin and end with main right here.
Yeah,
It's not going to do anything. But in this particular case, it stores it. Now we're actually putting it into a variable. So output of this program is still nothing. But we happen to have access to that variable for later use. Okay, we did do something with it. So now we can actually display it if we'd like. What's the output of this going to be now? Remember, I lie.
Oh, but it's going to be yes backwards.
You confident?
Confident.
All right, it's going to be yes backwards. Make sense? And because we wrote this generically, that is, we wrote it in terms of s.length and not some hard-coded value, or I guess as Nick would have had us do, just put some question marks. You said, who knows, right? So you would have wanted us to do that. Maybe 3 of them.
No, I mean, it can be anything, any input.
You
So,
can't.
I mean, you could say a larger word and I could say a smaller word, so that's why I don't know.
But it isn't anything. It's specifically s.length.
But it'll always change depending on the word.
But it'll always be s.length.
But
You know that now.
I already knew that. I was just.
That's not how you answered it.
Yeah, right.
I would give him a harder time, but I don't. He's not feeling well today, and it's true. He doesn't feel well today. He needs a hug.
You'll just squeeze the blood from that.
All right, so since I wrote this generically, I can now pass it any string I want. And now s.length will just be different. But it'll still boil down to the actual length of that string. So now we have it in reverse. Okay, so this allows us to do string manipulation without having to print things one character at a time. It also allows us to now have that string later on. Does that make sense? All right, so let's get rid of our crappy display method here. Let's say that I want to write a method to remove spaces. And that method takes a string as a parameter, and the string we pass it may or may not have spaces in it. But what we want it to do is we want to take that string and we want to return a new string that is the original string without any of the spaces that used to be there in it. So static string remove spaces. This guy will take a string s as a parameter. So as an example, if our input was hello world, the output should be hello world with all the spaces removed. That makes sense? Makes sense what we're trying to accomplish? That's if S happened to be hello world. S holds some string. And what's the length of that string? How many characters are in that string? It's always the same answer. How many characters are in the string S? S.length number of characters. Okay, because this is a variable. That's the point of methods, is that we can write it generically so that we can pass different values to it. Okay, so how many characters are in S? S.length number of characters. Okay, so we want to write this method such that whatever S is, it returns as a string a new string that has all the spaces from the original string removed. How would we accomplish this using only the tools that are in your toolbox?
Could use the. Could we do the same thing that we did with adding hello to worlds using a char space, but just minus the char space?
Minus char space. So you want to add a minus?
Yeah.
Add a nothing?
Yeah.
Okay, how would you do this in real life? So let's say that we have a bunch of characters. We're playing with our food. Was it the alphabet cereal? Okay, it's easier to play with than the alphabet pasta. So the cereal has the letters in it, and we're going to build out a sentence that has some spaces in it. And I want to remove all those spaces. You're going to squish them together, right? All right. Well, do we have any tools that allow us to squish a string together? Nope, so that solution's off the table. We've got to solve this in terms of the tools we have.
Well, what's a space? Is a space a char?
Space is a char.
And can't you just remove char space?
Okay, that's actually exactly what we're trying to accomplish, yes. So can you elaborate on how we might do that?
Assign the space a value.
Assign the space of value. But isn't a space a literal? You want to change the value of space so it's no longer a space?
Well, what would it be if you changed it?
Okay, let me throw this at you a little differently. What if instead of remove spaces, I wanted to replace all the spaces with question marks? So rather than that, the output's that. Using only tools that you currently have. Go ahead.
When you run through the string with a loop, like when you encounter a space, couldn't you, like say, just like replace with this if, like, it's a char space?
Okay, so we're going to have our normal loop that's going to run through the string, right? And every single time through, we're going to ask a question. How do we ask questions?
Statements?
If statements. So we're going to ask a question. We're going to ask, is the current character we're looking at a space? If it is, we're going to do what with it? Okay, do you know how to delete things from a string? Nope, so you better come up with a better answer. It's based on the tools that are in the toolbox in front of you. It's more of a lunchbox at this point.
What about that, I don't know, what we talked about yesterday, removing the blank spaces.
The blanks, well, that's what we're doing, is removing blank spaces.
So same thing how we did yesterday.
Well, that's a different class.
Oh, that doesn't work.
But when you say same thing, you still don't know what you're talking about. Let's start off by writing our loop. So let's write a loop that goes through every character in the string. So for int I is equal to what? What's our starting point? 0. We're going to keep going as long as what is true. I is less than s dot length. And we can say less than s dot length because less than s dot length is the same thing as saying less than or equal to s dot length minus 1, which is the last legal bucket. Okay? And then what are we going to do each time to I? Add 1. I plus plus. So that will take I on a voyage between 0 and whatever the last legal bucket of s is. Okay, and what are we doing here? We are building a new string. What was our pattern for building a new string? Probably starting off with a string, call it whatever you want. I happen to name it temp. And start off as the empty string. Something I can build a string onto. We're going to start off with nothingness, that is the empty string, and then start tacking crap onto it. Right? Okay. Now, if I'm not looking at a space, what do I want to do? And H becomes a what? An H. And E becomes a what? An E. So if I'm not looking at a space, what do I want to do? I do want to keep it, don't I? But do I need to do anything special to it? No, just keep it. And how do I keep it? I need to add it onto my temp using concatenation. So I'll ask the question, if. How do I ask the question if I am not looking at a space? What's the current character I'm looking at? How do we reference the current character we're looking at? What tool in your lunchbox is the one we would use to extract a particular char from a string? Char at. Okay, and I want to specifically get the char at I, the current character we're looking at. And how do I call char at? S.char at. Does that mean char at's an instance method or a class method? You say class? Okay, tell me why you're wrong. Who can tell him why he's wrong? How do you know it's an instance method, not a class method? S.char at I. What class does char at belong to? String class. How do we call class methods? Using the name of the class in which the method was defined. How are we calling the char at method? So S is the name of the string class. S is an instance of the string class. We call class methods using the name of the class in which the method was defined. We call instance methods using an instance of the class in which the method was defined. Char at's defined inside the string class. Since we're not calling it like string.charat, we're calling it s.charat or blah.charat, something that is a string rather than the string class itself. That means it's an instance method. Okay? And we're not looking for static or non-static because we're looking at the method being used as opposed to the method being defined. Make sense? Okay, so we get the current character by saying s.charat. Now I want to ask the question here. I want to build a Boolean expression. What's a Boolean expression? And the expression boils down to a single value of true or false. So I want to write the Boolean expression here that allows us to ask the question, is the current character I'm looking at not a space? How would you build that question? S.charat I not equal to, how would I write space? Single quote, space, single quote. The char version of a space. Because this is the primitive not equal to operator. It compares primitive types. So this is kind of like when we used double equal sign to compare strings and thought that was a bad idea. Okay, so we're comparing chars here, and chars are primitive types. So if the current character I'm looking at is not a space, what do we want to do with it? We want to keep it. So we're going to go ahead and tack it on as is to temp, right? So we'll say temp is equal to temp concatenated with s.charat I. Else. So if it's not a space, I'm just going to keep it. Tack it on as is. But what if it is a space? Let's go with a question mark version of this, where we replace all question marks, or all spaces with question marks. So if I am looking at a space, what do I want to do? I want that space to become what? Go ahead, Randy.
Concatenated to the temp variable.
Okay, we're going to what are we going to concatenate onto temp?
A string with question mark.
String with a question mark? Good enough. Could we also do a char with a question mark? Either one. Those are interchangeable in this particular case. So let's say temp is equal to temp concatenated with. We can either say that, or we can say that. Either one's acceptable because temp is a string. So we only need to worry about one side of the double of the plus sign being a string. But now what I'm going to do is I am going to do it as a string because that's going to help us with the other solution we're looking for. Okay? And I'll explain why we get to it. So what are we doing here? We're spinning through our string. Each time through, we're saying, am I looking at a space? If I'm not, just keep whatever's there. If I am, go ahead and just concatenate on a question mark, and we'll skip on to the next char in the string. Ultimately, since we've advertised we're going to return a string, I'm going to return temp. And then what I'll do is I'm going to call remove spaces. Hello world. We'll put one space in there. Here, we'll put some more spaces in there. There. Be fancier. We'll print that out. We should have all the spaces with some question marks. So now let's go back to the original task. I want to remove spaces. How would I remove spaces? I only need to change one little tiny thing in here.
Remove the question mark and put it as an empty string.
Put it as an empty string. Now the reason why I moved away from, so here I'll just go ahead and run that real quick, and we'll see all the spaces are now gone. Okay? So I actually have not removed spaces. I've kept non-spaces. Does that make sense? Did I even need this else? Well, I can remove that else. Just keep stuff that's not a space. If it's a space, I'm just going to ignore it and move on with my life. Same output. But now if we go back to that else real quick, remember originally he said the string question mark, and I sort of kind of talked him into the char question mark, then we went back to it. What if I was trying to modify that? And the reason why I want to show this as an after effect, is there a such thing as the char nothing? There is not. We can have the char representation of a space, but that's not what we're trying to do here. We're trying to remove spaces. So if we were to concatenate something on, we'd be looking for the nothing char, and that does not exist. The empty string does exist. That is the string that has no characters in it. Make sense? All right, for your homework, and I'll give you this as a starting point, write a method called remove vowels that removes all vowels from a string. And vowels are A, E, I, O, and U. You can choose whether or not you want to do the sometimes Y thing. I don't care.
Just like
Okay.
95%.
Make sense? Questions, comments, concerns, bribes? Huh? All right, I'll see everybody on Tuesday. Today's Thursday, right?
We're going to lunch, right?
Doesn't feel like it does it.